Hello everyone, welcome to the lecture. Today's topic is intermediate code generation. Introduction to the intermediate code generation. The front end translates a source program into an intermediate representation from which the back end generates the target code. The compiler can be divided into front end and back end. Front end of the compiler dealing with lexical analysis and parsing and syntax checking and generating the intermediate representation. Back end will translate the intermediate form of the code into target machine code. So, what are the benefits of using intermediate forms? Mainly two benefits. One is retargeting is facilitated. Retargeting is facilitated. That is, a compiler for a different machine can be created by attaching a backend for the new machine to an existing front end. That means, here no need to alter the existing front end, because the front end dealing with source code analysis and generating intermediate representation, so that no need to alter the front end. Only back end should be created and attached to the existing front end. That is the one of the benefits of the using intermediate form. Second benefit, machine independent code optimizer can be applied to the intermediate representation. That means code optimization means optimize the code. That means dead code will be eliminated by using code optimizer, and some other techniques will be used to improve the code. So, code optimizer can be only applied to the intermediate representation. Next, position of intermediate code generator. See, the front end dealing with lexical analysis and parsing and static checking, and also generate the intermediate code generator. So, intermediate code generator belongs to front end of the compiler. So, that back end will convert this intermediate code into code generator. That is intermediate code into target code by using code generation. There are three ways of intermediate representation. One is syntax tree, postfix notation, tree address code. First one, syntax tree. Syntax tree is a graphical representation of the source language. That means a syntax tree depicts the natural hierarchical structure of a source program, and DAG, directed acyclic graph, gives the same information as syntax tree but in more compact way, because common sub-expressions are identified and reused. A syntax tree and DAG for the assignment statement A is equals to B star minus C plus B star minus C are as follows. Here, this is the syntax tree for A is equals to B star minus C plus B star minus C. That means, first, this is minus C, that is unary, minus is unary operator, unary minus operator, unary minus, U minus means unary operator will be applied to a single operand, that is minus C. We can construct the syntax tree for this. Unary, C is unary minus, operator becomes the internal node of the syntax tree or parse tree. That means minus C, that is multiplied with B star unary minus, and also we have B star, another B star minus C, B star unary minus. These two sub expressions are added by using plus operator. So, total value of this expression will be assigned to a variable identifier A. This is assignment operator. So, minus unary minus C, B star unary minus C plus B star unary minus C. These two are added by using plus operator. The result will be assigned to identifier A. That is syntax tree. Coming to parse directed acyclic graph, it is also giving the same information as the syntax tree but in more compact way. That means it will identify the sub expressions, common sub expression. In this given sub expression, B star minus C is a common sub expression appearing two times, B star minus C plus B star minus C. So, for that, the DAG will be directed acyclic graph will be like this, B star unary minus C will be added like this, B star minus C by using this pointer added to B star minus C by using this pointer, and also the result will be, this is not star plus, B star minus C added to B star minus C by using this pointer, and the result will be assigned to A, identifier A. This is the syntax tree. Next, postfix notation. Postfix notation is a linearized representation of the syntax tree. It is a list of the nodes of the tree in which a node appears immediately after its children. See, this star is internal node having children plus and unary minus. Unary minus is a internal node having a child C. So, each node will appear after its children, immediately after its children. For this syntax tree, the postfix notation will be, first children will be appearing, that is first A, child top down evaluation of the tree, A, then B, then C, then unary minus, then star, then B, C, unary minus, star, plus assignment operator. Like that we can write the postfix notation for the syntax tree. See this, A, B, C, unary minus, star, B, C, unary minus, star, plus assignment operator. ABC unary minus, star, BC unary minus, star, plus assignment operator. ABC unary minus, star, BC unary minus, star, plus assignment operator. That is, it is a list of the nodes of the tree in which a node appears immediately after its children. The postfix notation for the syntax tree given above is this. Next, 3 address code. One of the intermediate representation, one of the form of the intermediate representation, 3 address code. 3 address code is a sequence of statements of the general form. General form of the 3 address code is X is equals to Y operator Z. Here OP representing any operator, any arithmetic expression operator. Then X, Y, Z are identifiers like names, constants, or compiler generated temporary, that is temporary variables, and OP stands for any operator. A source language expression like X plus Y star Z might be translated into sequence like this. See, X plus Y star Z will be converted into 3 address. That means here in the general form of the 3 address code, we have at most 3 addresses. X, Y, Z are the operands of the expression. Those are addresses, representing addresses. X, Y, Z are the addresses. So, any 3 address statement will contain at most 3 addresses like X, Y, Z, and the form will be X is equals to Y, OP, Z. Here in this given expression, X plus Y star Z having 2 operators, plus and star, but after is equal to operator, we have only one operator, 2 operands. The operator will be applied on 2 operands. So that we can write 3 address statement for X plus Y star Z will be, first we will take a temporary variable will be created by the compiler, T1 is equals to Y star Z. Y star Z will be multiplied and that will be assigned to T1. Next, T2, another temporary variable, T2 is equals to X plus T1. X plus T1. This is the intermediate, that is intermediate 3 address code representation of the expression, where T1 and T2 are the compiler generated temporary variables or names. Next, advantages of 3 address statements. Advantages of 3 address statements. The unraveling of complicated arithmetic expressions and of nested flow of control statements make the 3 address code desirable for target code generation and optimization. So, to optimize the code, we need to use 3 address code. Then here unraveling means making the complicated arithmetic expression into simpler and simple understanding way, simple manageable representation. So, unraveling means converting the complicated arithmetic expression into manageable and simple expressions. Like for example, A plus B star C minus D is an expression. This will be converted into 3 address code like this, taking temporary variable T1. T1 is equals to B star C. B star is multiplied, B and C are multiplied and assigned to, result will be assigned to temporary variable T1. Next, T2 is equals to A plus T1. T1 representing B star C. So, A plus B star C is evaluated and stored in temporary variable T2. Then, T3 is equals to T2 minus D. So, this is 3 address code. So, this complicated expression will be represented in easy and simple manageable representation and linear representation. Next, the use of names for the intermediate values computed by a program allows 3 address code to be easily arranged, unlike postfix notation. Here we can use the intermediate, that is the temporary variables for the names. Intermediate values, intermediate results will be stored in the temporary names, temporary variables. Next, 3 address code is a linearized representation of a syntax tree or DAG in which explicit names correspond to the interior nodes of the graph. For example, for the expression A is equal to B star minus C plus B star minus C, the syntax trees will be like this. Syntax trees will be here. For this expression, this is the syntax tree, this is the DAG. From this syntax tree, we can write the 3 address code. From this DAG, we can write the 3 address code. We know how to draw the syntax tree and DAG for the expression A is equal to B star minus C plus B star minus C. From this expression, we can write the 3 address code. How to write the 3 address code? Here, we are taking a temporary variable T1 is equal to minus C. I will write here itself. T1 is equals to temporary variable T1 is equals to minus C. Then T2 is equals to B star T1 and T3 is equals to minus C and T4 is equals to B star T3 and T5 is equals to T2 representing B star T1, that is minus C. B star minus C, that is T2 plus T4. T4 representing B star T3, that is minus C. B star minus C, 3, T4. T4 is equals to T2 plus T4. Then A is equals to this expression, that is A is assigned with T5. This is the 3 address statement for the given expression A is equal to B star minus C plus B star minus C. So, from this syntax tree also we can write this 3 address code. T1 is equal to unary minus C and T2 is equals to B star T1. This is T1. T1 will contain unary minus C. Then T2 will contain B star minus C. This is T2. This is T1. This is T2. Then this is T3. This is T4. So, this is T5. I will write T1 is equals to minus C, T2 is equals to B star T1, T3 is equals to minus C, T4 is equals to B star T3, T5 is equals to T2 plus T4, A is equals to T5. Like that you can write. So, this is the 3 address code corresponding to the syntax tree and DAG given above. For the expression A is equals to B star minus C plus B star minus C. So, T1 is equals to minus C, T2 is equals to B star T1, T3 is equal to minus C, T4 is equal to B star T3, T5 is equal to T2 plus T4, A is equal to T5. Like that, DAG, this is the 3 address code for DAG. T1 is equals to minus C, that is unary minus C, that is multiplied with B, then this will be added with pointers, result will be assigned to A. See, T1 is equal to minus C, this is T1, then T2 is equal to B star minus C, then T5 is equals to T2 plus T2, T2 plus T2, that is A is equals to T5. Then the reason for the term 3 address code is that each statement usually contains 3 addresses, at most 3 addresses, 2 for the operands and 1 for the result. See, this is the result, this is the operand, this is the result, these 2 are the operands, this is the operator. So, any 3 address statement will contain at most 3 addresses, that means at most means maximum 3 addresses and 1 operator. Thank you.